Good morning, Grizzlies. What is good? I hope you had an excellent weekend. We're getting down to the very end of the school year. So this week is pretty simple. We have an assignment today, and then on Thursday, we're going to take our very first quiz. That quiz will be Thursday and Thursday only. It'll be on two forms, standard form and Vertex form. Open note, open book. You could use your homework, anything that you've done so far. I think it won't be too bad. If you decide not to take the quiz, it won't hurt against your grade. So if you start it, you'll get a grade. If you decide not to take it, that's an option as well. After that, guys, we only have 2 weeks of school left. So a few opportunities to bump your grade up if that's something you're trying to do. Let's get started with today's lesson. Okay, so we have 3 forms of a quadratic, and they all do different things for us. We have the standard form of a quadratic, we have a vertex form, and we have an intercept form. This might be good to write down and maybe possibly use on your quiz Thursday, but if you already know it, that's great. Here's how we find the vertex when we're in standard form. Takes 2 steps. First, to find the x-coordinate of the vertex, I'm going to use the opposite of b divided by 2a. That's going to give me the x-coordinate of the vertex. So then what do I do with that number to find the y-coordinate? Exactly. We're going to take that number and we'll plug it into our equation. So once you know what x is, plug in to find y. Very, very simple. Then if I want to graph it, the vertex is the most important point, but there's only one point. So once I graph this point, I could put an axis of symmetry right through it down the middle. And then I use the a value to find 2 more accurate points. If a is positive, I'll go up that distance from the vertex. If a is negative, I'll go down that distance. I just put a dot to the right and left, and I'm finished. Now, if I'm in vertex form, this is very, very easy. That's why it's called vertex form, because finding the vertex is simple. I'm going to look at my equation. I'm going to use the opposite of whatever the h value is. Remember, that's a positive h. This is a negative h. So these numbers are always opposite of each other. And then the number on the outside, k value, goes right here. These numbers are always the same. You can see they're both positive. So I found the vertex just by looking at the equation. Then I can graph it. I'll graph wherever this point is. I can put an axis of symmetry right down the middle of it. And then again, use the a value to either go up, put a dot on the right and left, or go down, put a dot on right or left. Up is when a is positive, down is when a is negative. Finally, this is what we learned last week, is finding the vertex and graphing when we're in intercept form. Now, if I'm looking for the x-coordinate of the vertex, what I gotta do is I gotta find out where the 2 intercepts are first. I'm gonna take p and q, I'm gonna add those together and divide by 2. I'm gonna find out where the middle of the intercepts are. That tells me where the x-coordinate of the vertex is. Once I know this number, what do I do to find the y-coordinate? Just like we did in standard form, exactly. I'm going to take that number for x, I'm going to plug it back into the equation. So we plug it in to find y. These might be good notes that could help you on your quiz this week and a possible test that we'll have at the end of the year. This is kind of what we're ending with, quadratic equations. We have 3 different forms. So let's look at 2 examples, graph them, and then we'll have you try some for homework. All right, so my first example says y equals 4x squared plus 8x minus 1. Right away, I'm noticing this is in standard form. I don't even see parentheses here. So I'm in a standard form, and I'm going to use this to find the vertex. We're going to start here with the opposite of b divided by 2a. b is 8, so I have negative 8 divided by 2 times a, which is 4. Negative 8 divided by positive 8 is negative 1. So there's the x-coordinate of the vertex. Let's take this number and plug it in to find y. So 4 times negative 1 squared. I'm using parentheses. I'm protecting with parentheses there. This is going to give me, let's see. This is positive 4. This is negative 8. So we get negative 4 minus 1, which gives me negative 5. That's the y-coordinate. Let's go ahead and graph the vertex first. We've got negative 1 and 1, 2, 3, 4, 5. And I'm going to put an axis of symmetry. There's the middle of my quadratic. I've got the vertex. So now I'm going to go and look at the A value. The A value here was positive 4. So from here I'm going to go up 1, 2, 3, 4, put a dot to the right, put a dot to the left, and I am finished. Here's what that graph would look like. That was standard form. Now bonus points if you can describe all the transformations. So check this out. I can tell that it shifted to the left 1. It shifted down 5 because that's where the vertex is located. Because the A value is bigger than 1, it also has a vertical stretch. So bonus points today if you can include the transformations. Let's do one more example before we give you your homework. Okay, in this second example, I could see that I'm in vertex form here. I have x minus a number and x minus another number. So let's figure out what P and Q are and divide by 2. This one looks like it's going to cross at positive 5. This one's going to cross at positive 3. So to find the x coordinate, I'm going to add those two numbers up together and divide by 2. 8 divided by 2 is 4. So I have just now found the x coordinate of my vertex. Now, to take this number and plug it back into the equation, we're going to plug it in for x right here. Let's find the y coordinate. So I have 4 minus 5 multiplied by 4 minus 3. That's negative 1 times positive 1, which is negative 1. Here is my vertex. Let's graph that point first. It's the most important one. 1, 2, 3, 4, and negative 1. I'll put an axis of symmetry right down the middle. Then, just like in standard form, I want to find the A value. I want to look for the A value to graph a few more accurate points. The A value here is 1, which means I would go up 1, put a dot to the right, and put a dot to the left. Wouldn't you know it? It's supposed to cross at positive 5 and also cross the x-axis at positive 3. Check it out. There's positive 3 and there's positive 5. Those are the x-intercepts. Kind of cool how that worked out. Now, bonus points if you can describe all the transformations. Hey, the vertex is at 4, negative 1. That means it's shifting to the right 4, shifting down 1. Because the A value equals 1, it doesn't have a stretch, it doesn't have a shrink. That's it. There's only 2 transformations. It shifts to the right 4 and down 1. That's it. So, we've got 5 problems for homework to do. We're going to mix it up. Some are in standard, some are in vertex, some are in intercept form. If you don't have graph paper, you can make a sketch. That's totally fine. If you want extra points, go ahead and include the transformations. Go ahead and describe the transformations. We'll give you extra points for that. Have a great day, guys. We got a quiz coming up on Thursday. We'll see you next time.